In this video session, I would like to discuss about various temperature transducers. And we have first transducer is constant pressure transducer. Second one is constant volume temperature transducer. Third one is resistance thermometer, resistance measuring thermometer. Fourth one is thermocouple. And fifth one is normal glass bulb thermometer. So let us see first one, constant pressure transducer, or this transducer temperature measurement. Now, this constant transducer, constant pressure transducer, will be having a U-tube manometer, and one of end is connected to a capillary tube, and it is attached to a variable volume transducer. It senses temperature in a medium, and by we are trying to maintain some pressure, constant pressure. The pressure level we are trying to maintain a constant, and because of the temperature sensing, the volume of this transducer is varying. So this is a U-tube manometer. It is filled with mercury, and this column is same. The left hand and right hand column will be same. We are trying to maintain a constant pressure, and we are trying to sense the transducer of variable volume with respect to the medium. So here, what is it we are trying to find out is, we are trying to measure a temperature at a triple point, that is minus 273.13 degrees, 273.13 degrees Kelvin divided by volume at temperature. At this triple point, what is the volume? That is from the device we will be getting that data, and this multiplied by the current volume. What is the current? For any arbitrary temperature, say some 30-40 degrees, we are trying to range that temperature. We are trying to measure the temperature volume. So this is how we are going to get the temperature reading from this particular device, constant pressure device. The second one is constant volume temperature. Device. The difference between this constant pressure and constant volume, we can use the same setup, but this volume is made to be constant. This volume we are not trying to vary. When the temperature is being censored with this particular device, transducer device, the mercury or the sensing medium will try to expand, and the level of the mercury level will be increasing. So there is a height Z. Some height Z is being indicated. Now, because of this Z, the pressure we are going to get as, here it is P0 plus rho into G into Z. This is pressure we are trying to measure. So the temperature is calibrated against this particular height, and if it is 10 degrees, the Z column will be Z10, 20 degrees, Z20, like that the calibration will be done and you can measure. So here the theta is equal to again 273.13 divided by PT. A triple point, what is the standard pressure? Now use this constant and multiply with the corresponding P. We'll get the measurement of the temperature with the help of constant volume temperature device or measurement instrument. The third one is a resistance thermometer. In the resistance thermometer, we will use a Wheatstone bridge. Now in the Wheatstone bridge, one arm will be a variable resistance measurement, and the other arm will be a platinum coil will be used to measure the medium. And this is how a Wheatstone bridge is used. And when the temperature increases, the Wheatstone will balance in such a way that the resistance will be adjusted and the corresponding reading will be taken for resistance, and we can find out. So here R, the resistance will be equal to R0 plus 1 plus A T square, AT plus B, BT square. The T is the temperature and R is resistance. A, B are the constants. Now here, after finding out the resistance, the temperature will be calibrated with respect to resistance 273.13 by R into RT into R0 into R. And the next one is a thermocouple. The thermocouple will be based upon the Seebeck effect. In this thermocouple, now two dissimilar wires will be joined at one end, and the other two ends are immersed in a ice water mixture, and these two ends are connected to copper wires and this kind of potentiometer. And the medium will be sensed at this end. This is end A, and here the sensing of medium will be taking place. Now, because of this dissimilar temperature difference between two dissimilar materials, some EMF will be produced, and this EMF will be calibrated against the input temperature and output the measuring temperature. So here we have theta temperature is equal to 273.13 by epsilon T is EMF, that is electromotive force multiplied by the measured epsilon. So that is how we are going to discuss determine the temperature of a medium using a thermocouple transducer or a thermocouple temperature measurement device. And finally, we have a small thermometer, and this thermometer will be having in the bulb it is having a mercury, and the temperature medium will be sensed with respect to mercury, water or something like that. Now because of this temperature it will be raised, so the measurement will be used to read the height of the temperature, and corresponding temperature will be found out. Initially at normal temperature it will be having some low level, zero deviation. At 20 degrees, 30 degrees, 40 degrees like that, the corresponding temperature, the level will be indicating, and we are going to measure temperature. So there are different types of temperature transducers or temperature measurement devices that normally in use by various manufacturers. Thank you for listening lecture.